right, here we go. All right, let's drop it in the channel. There we go. All right, we get to try the Pro Zoom today. Your boy had to spend money on his own Zoom account just so students don't have to break it up into two separate videos. Let's close this like that. Catherine and Tania. Catherine and Tania. Ooh, Louise. I think I know that. Hey, Lorelai.
Baby girl.
Baby girl. It's almost bedtime.
Cutie.
Are you guys on Eastern, Louise? Eastern Standard Time? Yeah, us too. So she probably goes to bed at like 8, 7:30, 8 o'clock. Lorelai. Jade. So we'll try this this new Zoom out tonight, Lorelai. We got a pro Zoom account, girl. Pro status. Hashtag pro status. Hashtag balling on a budget. $14.99. She's clapping for me. She clapping for me now. Clapping for us because we no longer have to break them up into two separate Zooms. Okay, so Obeda will. I don't think Obeda is going to be here. He's at a wedding. Get ready for that. We're just waiting for Nikki and Dez and Bryant.
That's like a good way to save money. Have your wedding on a Thursday.
So let's see, Obeda and yeah, Beta makes 4. Okay. Yeah. All right, let's go around. Oh, there's Nikki. And we'll give it another minute or so here. What's up, Nikki?
Hi.
Lorelai. Dang, I mean, I feel like I should go get my daughter. And Nikki, you should go get your daughter. And
No. My baby.
No? Okay. All right. Okay. Might complicate things a little bit.
She talks too much. Overexcited.
Hey, that's how kids should be, right?
I know.
Right? I mean, you can't be hindering that. That's her. That's Nyla. Huh?
How old is Louise, baby?
Louise, how old is Lorelai? 1 year old. Is she up and walking yet? And no problems? No.
She's taken a few steps. She just turned 1 like last week.
Oh, sweet. Cool. There's Bryant. All right.
No baby fever. No baby fever.
Bryant in the house. Okay, let's we'll get started. Desiree will probably hop in here pretty soon. Then Obeda, like I said, is at a wedding. So 60 seconds, any breakthroughs you had. Let's go with Jade first.
Today went really well. Catherine's videos helped a lot, and I actually had pen and paper and start drawing everything. So I was able to not only do stretch or do MVP, but I got to those 2 stretch problems as well. So that felt good for a change.
Hey.
So that was my breakthrough. Popcorn, Elise.
My day, not bad. I did like a little bit of review from yesterday's stuff and just trying to make sure I solidified that. Haven't hit MVP, but working on it. Don't really have any massive issues. It's just syntax for me, I guess. So yeah. Let's go with Nikki. I was like thinking in my head, I wasn't sure if you had gone. I always think of our conversations in the beginning as you going. I apologize. Sorry.
No problem. I won't say much. I'm just coming to say bye to you guys because I am gonna flex, take a little break because I'm a little bit overwhelmed. I have a lot going on in my life right now. So, and computer science is not making it easy for me. My daughter needs so much of my attention. It's been 7 months of grayness and craziness and all kinds of personal stuff. So I'm just gonna take a little break. I'm gonna get emotional, but
Miss
Tico is like
you.
the best
Yeah,
leader ever. So
we're gonna miss you for sure.
yeah, definitely. But I
Yeah.
need the break, so I can't
Yep.
do it
Yep.
anymore. So,
Yeah.
yeah.
No, it's good that you recognize that. Unlike I did last night where I stayed up too late, but yeah, it's good that you recognize when you need
Yeah.
more time.
It's
It's
this
really
or
good.
I'm gonna be divorced in a couple of months. So
Hey, I can vouch for that. Five-year anniversary dinner was skipped on the day that I failed the graph sprint 3 times in a row that same day. I asked if I could reschedule the 5-year anniversary dinner. It was so stupid. Yeah. But we're gonna miss you so much, and you bring a lot to this group. And either way, you'll always be part of the group, so you can always come back in. I'm not gonna kick you out of the channel or anything like that. So, of
yeah, thank you. I really appreciate it.
course, thank you. Want to pick somebody, Nikki?
Bryant.
Yeah, first of all, best of luck, Nikki. I've done a flex myself way back in Redux. Life got a little crazy, and I really thankful for it because I got to know my stuff. Um, yeah, I was the best at Redux. Anyway, yeah, I say blockers today. I overthink recursion problems, and it's just like a habit again too. And I can make it too complex, and I think I just need more keep practicing recursion problems. And the more I practice, the better they get. And it's always like a third of the line. The answer is like a third of the line of what I originally think it is. But other than that, everything's going well. So yeah. Okay, I don't think we heard from Tanya.
First off, gonna miss you, Nikki. We started in the same group at the beginning and we were ending in the same group, but there's still no concretes that I won't be joining you. I'm still struggling on my sprints, week after week, so who knows. But yeah, so I worked with Jade today and fleshed out some code, but it's not passing. And Luis is trying to help me, but I'm still confused and stuff. So Catherine.
Yeah, it's gonna be sad to see you go, Nikki. But I mean, you gotta do what's best for you, and I mean, take the time you need. Yeah, today. I think with the combination of the videos that I'd watched and the lecture, things just like clicked more for me. But I mean, I literally went and looked at that material like 6 times before now I have a more solid take on it. So yeah. Okay. Who hasn't gone?
I haven't.
Desiree and Elise and Luis.
Desiree?
So I am extremely far behind because I've been out sick, as you guys probably know. I had flu, so yeah. And so there is a possibility that I may be flexing as well. I haven't decided word yet about that. I may be flexing also. And so today I just kind of tried to get as caught up as I possibly could. I'm struggling with recursion. I seem to be getting an error that says that's hitting like the recursions, the stack limit. And so I'm not really sure why that's happening. So yeah.
We can take a look at that afterwards.
Yeah, so that's what I've been dealing with today. Cute baby.
All right, Des, if you want to pick somebody, I believe the people who haven't gone yet are going to be Elise and Luis.
Okay, Luis.
Today went pretty well. Blocker that I had for a little while was tracing back. That's actually what I was trying to help Tani with. Was tracing back what's returned from like when you pass an NQ or when you pop out of the stack. And once I figured that out, because when you're looking at the lecture and the way you went over things in the lecture, it's slightly different. And that kind of threw me. Oh yeah, it kind of threw me for a loop. So once you get through that, it's a little bit easier to like kind of digest. And yeah, that was it. I think Elise did go, yeah.
Wait, Elise, you really went?
Yeah, I picked her.
Oh my gosh, I'm so sorry. I'm sorry. Oh, maybe I was thinking like, okay, like Elise, you want to like, you know, like say your goodbyes to Nikki and stuff like that too. Maybe that's why.
Trying to make up for yesterday when you forgot.
Maybe.
She was like, you go twice.
No, okay.
No, like for sure. I was just gonna say, you know, I had to do the same. Like, and life works in mysterious ways. I was just telling Tigo, like, I've kind of been a stubborn individual when having to flex, and you know, it's been extremely beneficial. So, you know, just make sure you don't leave the channel, okay? That's all I ask. Just don't leave the channel. Do what's best for you. Just don't leave the channel.
Yeah, definitely.
Thanks for that, Elise. Okay, so today I figure we could go ahead and look at, I was going to look at the sprint because everybody has access to the sprint, right? Technically, you all have access to the sprint.
Could we at some point, can someone help me figure out why it's not? Okay. Because
we could do that first.
Yeah, Jade and I compared, and our code is very, very similar, and hers is passing and mine's not.
Okay. Let's can we help Desiree first because her problem is from last week's recursion issue, and then maybe somebody could just knock that one out, and then we'll come around to Tani's.
I think you should go to Tani's first.
Well, actually, if we solve your problem first, I mean, you may even benefit from the explanation that everyone's going to give for Tani's code, because this builds on top of that.
Okay, I'm just kind of TLing right now as well, so
okay,
I'm a little distracted.
So Des's error message was that she was getting maximum depth with the stack, right? So that's usually an issue with what? Does anybody know? Can somebody give her?
Infinite looping.
Mm-hmm. So what does she need to account for? Does anybody know?
A base case to make it stop.
There you go. So go ahead and explain what you got here, Des, if you can.
So in the merge sort, passing in an array, and then I am splitting the array into 2 halves. And then if that half is equal to 1, if both halves are equal to 1, then right now I'm just trying to print them. And then if they are more than one, the length of them, if they're more than one, then I'm putting them back into the merge sort. So if I like take out these, it returns sorry, my computer is slow. Okay, it was returning. I'm not sure why it's not now.
I see the error right there. Recursion error.
Mhm.
Maximum recursion depth exceeded while calling a Python object. So yeah, like just like was it Catherine said that we need to create a base case. So do you know what a base case does?
Yeah, it's like the smallest unit of the problem.
Yeah, and then also you'll need to like somehow increment or decrement like down to that level. So that way they in some sort of loop usually. So can somebody help lead her in the right direction of what she could do first? Anybody? All right, so Des, in this function, you also have to use the helper function, right?
Yes.
Can you show us that helper function?
Yes, but it's not, I haven't done anything to it yet.
Okay. So do you know what the helper function is doing compared to what the merge sort function is doing?
Yeah, it's actually sorting the items into a new array where everything is sorted and merged. It's like merging everything together, but sorted.
Okay. So where could you establish like a base case, I guess?
Well, I assumed that I was establishing it in the merge sort.
Mm-hmm. Correct.
So is line 69 not a base case?
Not for this specific, no.
Do you not have to code the merge helper function first?
I actually did it opposite. I coded the merge sort first and figured out what the base case was first.
Okay, can you walk us through that, Jade?
So I'm trying to remember how I did this. Sorry. I think what I ended up doing was instead of putting like the left and right into the merge sort, I decided that merge sort is just going to be like my base case is going to be the full length of like the single array, because the we're dividing the array into subarrays here. And so we need to actually, like, let's see if I'm explaining this right. We need to actually, we're dividing it in half, but what are we taking in as our base case? Like what is the user input or the input? Is it two different arrays or are we doing a single array?
We're doing one array for the merge sort.
Yeah, so for this particular thing, your base case is actually going to be that single input. So that will be the single array itself. So that is your base case.
Okay, so like if array.
So you actually don't have to do an if statement
Okay.
because we have a single array. I'm trying to do this without giving away the answers. I don't know if I'm doing a good job.
No, it's good.
So basically, if we're taking in that single array, what do we need to do in order to like divide it in half? Like before you even get to the division part, what do we need to do?
I'm not sure.
So what we would need to do is we actually need to be able to find its length. Before we can cut anything in half, we need to find the full length of it.
Okay.
So what I ended up doing was creating a variable that equals the full length of the array.
Okay.
Oh, it looks like you even did that, huh, Des? Line 65.
Yeah.
Just had it commented out. Okay.
Yeah. And then what I did was then I created, and I don't know if this is doing way too much or simplifying it a little bit, but then what I did was I took that single array because the next thing we have to do is we have to divide it in half, correct?
Mm-hmm.
So then like you have here split, you take split and then you can divide that in half and that will always be your mid variable.
Right. So just divide split in half.
Mm-hmm. Mm-hmm.
But as another variable, right?
Yeah,
Okay.
as another variable because for me, I needed to be able to use mid.
Yeah.
Inside.
There you go.
Okay, so we're doing the split. So inside of your if statement can be a lot simpler here. Instead of doing like how you have the left half and the right half, this half variable takes care of all of that for us. And so does the split variable. So you don't actually need to do length left half is equal to 1 and then the length of right half equals to 1. What can we do to sum that all up? You have two variables split in half, but you can actually use just one of those to see if it's equal to 1. Does that make sense, or did I confuse you?
I got lost, I think.
Okay, all right.
So let me see if I can help out here. So
yeah.
Des, basically what Jade is saying is, see how you basically hard coded left half and right half. What she did on line 65 is, hey, I'm going to create like a variable that's just going to represent like basically the whole length of the array, and I'm going to create another variable called half, which is going to represent any half. It could be left half or right half, right? And so now like you have like these generic terms you can use to describe left half and right half without using left half and right half, and without having to hard code like the specific spots where you're slicing and all that stuff. She's saying that you can now simplify line 70, so you won't have to have like two conditional statements inside of your if. You can just have one conditional that can be described using the term half.
Okay, so if half or I don't know.
Yep.
What are we comparing the half to?
You can do one of two things. You can do the half, or because in order to, the way it works is if the array is bigger than 1, we want to keep dividing, right?
Mm-hmm.
So what I ended up doing was using split here. So I said, for your example, if split is bigger than 1, then what you can do is kind of use what you have in 70 and 71. And all you're going to do is use mid inside of what you already have here. You just won't have to do the division inside. So like you can use like let's start with 70. You said that's the left half. Yep. And then, so you're close. There you go. So then there's only one other thing we have to consider. This is the part where we would do the recursion.
And I feel like every time I hear that, I power up like Super Mario Brothers.
I'm sorry, 1 second.
No,
you're
sorry.
doing, you're doing good.
Okay.
Okay, so do you remember or what recursion is? Like, what do we do with recursion?
We send it back into the function. If it's not, if it's, so like if the, so if the array is not a length of 1, then we send it back into the merge sort function.
Yep. So then how would we do that that recursion on line 68? Looking at
On
line
68?
So we have line 68. We're just missing one part, and that's the actual cursive part. If you compare what you have to line 63, that kind of gives you the answer of what recursion actually does.
Here's another clue, Des. What happens when you take a mirror and you take another mirror and you face them towards each other and you look inside the mirrors like this? It just keeps going back and forth forever, right?
Mm-hmm.
So then, like, what she's saying is take a mirror and put it on line 68. Because right now you have a mirror on line 63 that's facing one way. Take another mirror and put it on line 68. And make it face. Oh, you had it right, would you? Yeah. There you go.
Now
Like
just bring back your left half equals to what you just wrote. So you can keep the merge sort and all of that there. Your left
She meant
half.
like as a outside the merge sort call there. Yeah. There you go.
So, sorry, I'm not good at this, so I apologize. I'm
Good at
probably
what?
not absorbing much of this.
You're not good at what?
I said I'm not good at this, so I apologize. So I'm probably not absorbing much of it. So I'm so sorry. But
No, don't even apologize. This actually,
Yeah, what do you apologize
I was
for?
behind like 3 days on this before I figured this part out. And I just looked back at my code and I haven't even finished the upper one. So you're totally fine. You're good.
That's what we do, Des.
So I don't need this part because that's up here now.
Mm-hmm.
And I'm just returning the array.
I believe so. I think you're just going to return like the full array. Now I don't know if this will take care of the loop because we don't have the other part attached to it, the actual merge. But this is what I had so far.
So we still have to go up and basically flesh out the merge function up top, right?
Yeah.
So how would you, like, where in your merge sort function could you use that helper function?
So originally I had it where if it was equal to 1, then it would go into the merge.
Mm-hmm.
But because I didn't have that there yet, I was just trying to print it to see if that part even just worked.
Okay. Actually, line 75 looks correct. So you could declare that on line 70 because it is right, line 75. and then you could just return. Well, you have to set it. You have to like declare a variable and then set it equal to what you have on line 75. On line 70, you do that.
Maya, hold on 1 second. I'm sorry.
Let's go.
Can you go? Hold on. I'm so sorry.
It's all right. Well, she does that. We could. Okay. She's back.
Okay, so we have to set it equal to a variable, you said?
So like just like on line 68 and 69, you made like a left half and a right half variable. You just want to create something that you can return that would be set equal to that array that the big array that you're merging both small arrays into. So you can call it anything right there. You can call it, I don't know, array if you want, or call it new array or something. I don't know. Yeah. And then you'd pass in, what you have on line 75. There you go. And then maybe just align it with the left and the right half that you have there on line 70. Just make there you go. Yeah, looks good. And now it's got to define your. Go
But
ahead.
I'm confused now because if it it's greater than 1, I don't want to push it into the merge, do I?
You do, because the split, what you're doing is you're just making sure that you actually have an array that's bigger than just like an index of like 0, just 1. If I remember it correctly, you want something that you can at least divide in half.
Okay, so when is the sort? When is the array being split down to 1, to a length of 1?
That's where I believe, so we split it with the half split. We're going to keep doing that until we come up to exactly 1 individual for each. So like your test array here. So this is going to split it up to where 1 becomes its individual array, 0, 2, and 9. So that's actually doing the splitting. And then
Go ahead.
And then what line 70 is going to do is once you define the merge function up above the method, that will actually move them all back together. And this is the part that like confused me, and it took me a long time to figure that out.
Yo, Des, check this out. Sorry, Jade.
No, go ahead.
I was gonna say if you can rename the variable on line 65, it's kind of like it's confusing because you're calling it split, but you're just getting the length of the array. So maybe we can call it like length or something. And then on line 70, you calling it something. Maybe we can call it like new array or like something that will describe like that array that's going to be basically merging the other 2 arrays. And then Elise had a really ridiculously super good example last week of how she viewed merge sort. And she explained it to me in terms of teddy bears. And I feel like if she explained it to you right now, it might really help you understand it a little bit better. Please, Elise. Elise, not Louise. Elise.
Sorry, I didn't hear the beginning because my internet was being weird.
Oh, no problem. The teddy bear merge sort analogy that you use. Can you explain that to her so she can get this, please?
Yeah.
Light bulb. So get this light bulb real quick, please.
Tani is probably going to be so mad. This is the 3rd time she's heard this explanation.
I'm into it, Elise. I'm into it.
All right. So merge sort is basically we're going to take 4 teddy bears. So with those 4 teddy bears, you need to break them down. So what we're going to do first is take the 4 teddy bears and break it down into 2 groups of 2 teddy bears. And then from there, we're going to break the 2 groups of teddy bears into each bear is basically in their own array at that point. And that's how we break down the merge sort. That helps.
Yeah, that definitely helps. I think where I'm confused about is how I don't know. I'm just confused about how we then pass that into the merge array. So
Can you change on line 78, Des, the array that you're returning?
what should I change it to?
What do you think?
Thanks, Elise.
No problem.
What do you think, Des?
Well, I was asking you what should I change it to?
That's what I mean. I'm asking you, like, what do you expect to change it to? Because you got to have an opinion. So then that way you can either be wrong or right. Because if you're afraid to be wrong, then you're not really that invested.
Original array?
So like we should be returning the array that's being declared on line 70, right? Luis shaking his head.
Yeah, definitely.
Right, because that's the one that you want to return. You
Okay,
you
so
like
new
spent all
array?
that work. You spent all that time and effort, right? Sorting those teddy bears, right? So you might as well return that bad boy, and so you can give it to your daughter. You know what I'm saying? Because her teddy bears are all out of sorts. So sort them bad boys. Okay. So merge sort function looks good. What do we need to fix in this merge function up top here? What do you know about merge sort based on like what Elise just described to you there with the teddy bears? Or can you just can you explain what's happening on like line 54 and 56?
Yes. On line 54, it is calculating the length of the combined arrays. On line 56, it's creating a list of zeros with that length that we calculated on line 54.
Very good. Why would it be important that we have a list of like an array of a bunch of zeros that's the same length as length of array A plus length of array B?
So that we can have a place to sort into.
Yeah, exactly. So then now we just need to sort, right?
Right.
Okay, so then now that you've created this, like you've created this super long list with like a bunch of zeros that act as placeholders for where you're gonna put these teddy bears, like how would you go about going through that array, I guess, and then that new list and putting it inside of, I guess, and sorting all these teddy bears?
I mean, from what I know about merge sort, you would, I guess, iterate over the arrays, compare the first two, and then whichever one is smallest, append it to the merged array. But I don't know if it's append or since we have an array with zeros in it already, do we just add it to the specific index?
Yes. Yep, you are correct. So let's do it. Get your hands dirty, girl. Do it. At least over give me a victory dance.
Give me 1 second.
Yeah, no problem. And just so you know, Tani, don't be getting all like scared and stuff. Like we're not gonna go over your problem. I'm gonna be here to go over with you. Anybody else that needs to leave, it's 5 till. So if you have to go, you're okay to go. But I'll be here finishing up with Tani, and we'll also go over the sprint. And for those of you that can't stay, that's why I've recorded this with the pro status, the pro Zoom. So it'll only be in one video. You won't have to split it up in 2. See you, Luis.
They will give you pro that I'm leaving, huh?
What's that?
They will
I know, right? I would get pro right when we left. I know, Nikki. Oh, I'm so sorry.
Oh, you guys have a good night.
Oh,
Bye.
you too.
Bye, Nikki.
Bye, Nikki.
Bye.
Good
Gonna miss
luck.
you.
I will miss you guys too.
Good luck.
Thanks.
Tell Nyla we said bye.
I will.
Okay.
All right, I'm back.
All right. Let's do it. Elise, can you give her a good starting jumping position for this loop that she's about to loop through? Like, what is she looping through? What could teddy bears, or what are we looping through?
We are looping through, for sure, some teddy bears. But basically what we need to do, let's see, where are we at?
You're in the merge function.
We're in the merged R. So we need to loop through the length of, oh, this is the merge function. Sorry.
The helper function.
Yeah, okay. So in order to start this, oh God, I feel like merge sort has disappeared from my brain for some odd reason.
That was just last week.
I know, we go through this stuff so fast. It's not my fault.
I forgot about them teddy bears already.
No, I remember the teddy bears, the code. Yeah. All right. It logically, looking at this, we need to loop through. So technically we need to loop through both the length of the arrays, right? Like, sorry, I couldn't tell if my internet was sucky or if you were in mannequin mode.
Make sure to talk to Desiree, because she's the one that it's her problem here.
I feel like
trying to help her.
right now I'm in the same boat as Desiree. We might be paddling in circles.
Backtracking, I loved your mannequin mode. I'm going to start using that. Mannequin mode engaged.
Right. All right. So complete the helper function below to merge 2 sorted arrays. So this part is saying line 56, the merged array is equal to, or we're assigning it to 0 times all the elements, which is basically starting from the beginning and just going through the entire array. That's what line 56 is doing, correct? I'm no help right now. I feel
you
like.
are. Stop it. You are helping right now. Des, can you answer her question, please?
I think so. From my understanding of line 56 is that it's creating a list of all zeros with the length of the combined arrays.
Right. So like the way I'm thinking of it is, okay, so I have 5 teddy bears in array 1. I have 5 teddy bears in array 2. So if I merge those 2 together, how long should the big group of teddy bears be?
7 bears long. You said 5 and 2, correct?
Did I say 5 and 2? Oh yeah. So 5 and 2. They would be 7 then if you're adding those 2, right?
Okay. So if we're looping through it, we need to basically say, so.
I'm sorry.
Danangra powering up over there. You're about to win the game, whatever game you're playing right now, Tetris or Super Mario Brothers or.
To start.
Students that need help.
So it would be if merged _ r dot length is greater than 0. Is
So-
that how we would start the loop?
Well, we would need a.
Oh, sorry.
Go ahead. But just keep going with where you're going. Keep going with where you're going with. Tani, if you have any thing that you can drop in here as well in
If
terms
you
of.
could throw
well,
me lifesaver, that would be great.
Tani, come on now. Help a sister out now.
Oh.
My mouth is in mannequin mode. I don't remember, guys.
So it's supposed to be a for loop, right? So
There you go.
Yeah, for sure.
So I
I just
apologize.
don't know how to do it.
So it's, and then you do your range as the elements for the for loop.
Oh, that makes
yes.
Sorry.
Thank you.
Des,
for
tell them they can wait, Des.
lifesaver.
Des, tell them they can wait.
I don't know how much they can wait, but
Tell them
okay.
students they can wait. All right, because you gotta put your own oxygen mask on before you start putting oxygen masks on for other people.
Nailed it.
So 58 would be a for loop.
Okay.
So for, you can do simply like I and range parentheses, and inside would be elements, because this is how we loop through the elements, which is
Or
going to be
even
the
element in range,
Oh yeah, you could do that.
right? Just to make it clearer.
Say it again?
Could she change I to element just to make it clearer for her?
Yeah, she could. Yeah, that's a good, very semantic way of looking at it.
No S, just singular. That's your iterator.
Good.
Yeah, so you're looking at one element at a time.
Here we go. Okay. So what's next, Des? Like, just make a guess, a wild guess. We will answer your questions. You ask the questions. We'll actually probably ask your questions back.
Okay. I'm going to try to formulate a question.
Because you said that you learn the best by doing, right? You don't learn the best by watching or listening or what have you. So if you just start doing, then we can say, hey, like, why don't you try this? Why don't you try that? So just walk us out loud, like what is going through your brain, and we can just help guide you there.
So I'm trying to figure out what to put on line 59 right now.
Mm-hmm.
And I'm not quite sure what to put on line 59 right now.
Well, if it's, are you just nervous? Do you think it's just because you're nervous, or like you're sharing your code in front of people, or?
No, I'm not nervous.
Okay, because you told me earlier, I know you know what merge is doing, right? I know you know what it's doing. Like, so just roll with that. Roll with your gut right now.
I don't know if this would help, but basically at this point you're saying for each element that's in range, so for each element that's in the array, now you want to tell it specifically what you want it to do. So for this merge, it says complete the helper function below to merge two sorted arrays. So you've already told it what you want it to look for. Now you have to tell it what to do. My wheels
Nice.
are starting to kick in a little bit.
There you go. Get them wheels going.
So yeah, you've started it. So now you just need to tell it exactly what you want it to do. So you can basically use it down below to do a merge. Sort.
That was a good tip. We just have to get Desiree invested enough that she is okay with making a wrong decision right now. Because right now I think she's just too afraid to make the wrong decision, and so that's holding her back. There we go. Okay, there we go. Now you're at least making a decision.
Yes.
Okay, all right. So like tell us what you're doing here.
I am appending something to the merged array.
Mm-hmm. And what is your justification for appending?
to add the element to the array that was created.
Okay. On line 56, does that line tell you if there's anything already in the array or?
Yes, there is already something in the array. It's a list of zeros.
Right. So if the list of zeros right now is already equal to the length of the full merged array that you want, do you have to add anything in there, or could you just end up probably just accessing the ones that you want?
I can access the ones that I want, I guess.
There you go. So how can we change what you have on line 59 to, instead of adding it, just accessing it? Now we're on the right track now. But so that 0, so that's essentially saying what?
The index of 0 in the merged array.
And so, like, how do we make it more dynamic? Like, instead of hard coding the 0 in there, what could you pass in there that would allow you to? Tani said it earlier. Would allow you to have access to the iterator.
Elements.
Okay. I have to go put my daughter to bed. I'll be right back. Keep going though.
She's so cute.
Okay. I don't know. So we're accessing each of the, I'm sorry, y'all, my SL is still blowing me up.
Go do what you gotta do.
So we're accessing the array at each element, and I have to set it equal to something, to whatever the value is in each of the arrays. Right?
I believe so. This is the part I don't have filled out, so I'm doing this with you. I think that's right. Tani, Lise?
Mine was different because I didn't use the elements. Like I commented out and did.
Oh, I see. You're saying like the way you did it was in your for loop, is that when you joined the arrays instead of using line 54, Tani?
Yeah.
I see. That's what I keep thinking. Like, I keep thinking like, all right, how do we do it?
Change the sound.
Like, why is nothing coming to my brain?
But how? Okay, so for each of the elements in the length of the array, we're accessing merged array at that element. I just don't know how to incorporate array A and array B.
Okay. Jade, any hints we can give her?
I'm at the same point she is because I actually didn't finish this part. I thought I did, but I hadn't.
Okay, so this is perfect then. Okay, that's a really, so Des, like you being aware of that, like how do I incorporate in it? It's really, really good. So right above your for loop, can we declare some variables that would help us, I guess, have something to compare to when we're comparing like the length of like say array A or array B?
Like how like we need to set something up so we know when all of the elements in array A have been merged, right?
So you're saying like set up a variable like A equals array A, B equals array B, that type of thing?
Yeah, A
Or
equals,
Simplified.
length of.
A equals what?
I was doing A equals array A, B equals array B, and I'm not sure if we need to look at the length of those or just looking at each individual that gets plugged in.
Yes and no. So we do have to declare on lines, that'd be line 57 and 57.5. We'd have to declare like an A and B variable. But basically, we need to know, okay, so anytime you would set something from array A, or sorry, from array A or B into the merged array, we need to figure out, like, have we already merged that item? And like, how do we keep track of the items that aren't merged yet? Does that make sense? Man, I feel like I need to draw this. Hold on. Put the baby away real quick. Okay. Handy dandy whiteboard. Hello.
We need to check the lengths to see if they're smaller than the length of array A.
Mm-hmm.
Or
So we need to. So I think I need like a summary after we do like the trying to figure it out part, because I get lost and so I don't know what the end result is.
No problem, Des. That's a good thing to know. So right now, if we're talking about the way that Elise was explaining it, right? You have teddy bears, right? So let's say we have how many is that?
If
That's
you
7.
stop sharing for a little bit, Desiree, then his screen will get larger.
Okay. You guys see my screen okay? Okay. So basically we have these teddy bears, right? All these different teddy bears. We have 7 of them. So what merge sort is doing is, like, we're taking, I guess, 2 different arrays. So merge sort says what, Elise? Can you explain your analogy again, and I'll help draw it here?
She stepped away for a minute.
Oh, okay. So
your
basically, go ahead, Jade.
So this is when we're actually dividing first, the teddy bears?
Yeah,
So,
yep.
So we have these 7 teddy bears, and so we try to divide it in half, and now we have 2 arrays, one that has 3 teddy bears, one that has 4 teddy bears. And we keep doing that and keep dividing them until we have each single teddy bear in their own array. So that'll give you 7 different arrays.
Yeah.
Teddy bears.
Okay. And then what's next, Jade?
Now that we have them, we need to be able to compare the first 2 arrays and compare which one is bigger or which one is smaller.
Here.
No, the 7 individual ones.
Oh, these ones here.
Oh,
okay.
yeah, sorry, I wasn't sure where you were pointing. So we need to be able to only compare the first 2 based off that they're both the length of like 0, they equal 0 index, so they're the length of 1. And then, so if teddy bear, let's just say this is like size. So if teddy bear the first teddy bear is like an extra small.
Okay.
And the next one's an extra small. Or we want to leave that alone.
Right, because they're merged, they're sorted already, right?
Yeah, they're sorted already.
Okay.
Now this is where I'm a little no, I think this is right. Then you want to compare the extra small and say the next size is a medium. I might be backwards on this.
Can anybody else hop in?
I thought
Des?
that
Yeah.
you,
Go ahead, Des.
I thought that you were supposed to compare each pair. So like the first 2 pairs you compare and sort them. Then the second 2 pairs you compare and then sort them. And the third 2 pairs you compare and sort them. And
She's
then
right.
you have to go back and
That's correct.
do it again.
Sorry, I
That's
was getting
correct.
mixed. I was getting mixed
That's
up
right.
with bubble sort.
It's all right. So like this process right now, like everybody's learning right now. So like she's right. So Des, we're comparing these 2, then we're comparing these 2, right? These 2, and then this one. Let's just make it 8 to make it easy.
Can we
Yeah.
assign the teddy bears some numbers?
Yes, we can. Sorry, I got caught up in the cuteness of the bears, and then I wanted to. Yes, we can assign the teddy bears some numbers. Good thinking. Okay. Let's do 6, 7, 4, 1, 2, 3, 5, 8. Okay. Tell me what to do next, ladies. I'll be your Vanna White.
So you compare the 7 and the 6 to see if it's in the right order.
Goody. Oh.
And if it's in the right order, you just merge them together into one array.
Okay.
One sorted array.
Okay. So you said compare. I'm gonna recap for you. Compare these 2. If they're already sorted, go ahead and merge them into the merged array.
Right.
Right? Because like the merged array, like we've already created, it's like this array with like all these zeros already into it, right?
Right.
And then we don't have to add anything in there because like we have those zeros as placeholders. We can literally just pick the index, right?
So as the problem is written right now, because we're only comparing 2 arrays, 2 arrays with length of 1, our merged array actually only has 2 zeros in it.
Wait, say it again.
So right now we're only comparing the first 2 arrays of 6 and 7.
Okay.
So the length of each of those arrays are 1. So because the length of each of those arrays are 1, then the length of the merged array should be 2. So it should only be 2 zeros in that array.
That would be, I would agree with you, but in our code, do you remember that part where we did elements times 0? And elements was equal to the length of array A plus the length of array B?
Right, so at any given time, we're only passing in 2 arrays, right? So right now we're just passing in those 2 arrays, 6 and 7. So right now, our array only has 2 zeros in it.
Can Tani and Elise confirm this? Are they even there? Is Tani cooking some sort of vegetarian dinner right now?
I'm here. I may have zoned out.
Okay.
Sorry.
It's all right.
I wasn't actively engaged, so.
Hop in and engage, please, because you're mannequin mode right now.
I'm sorry, what? So the question is, does the merged array only have these 2 items?
Yeah. So how many items would the merged array have if this is our first comparison right here? So we're comparing 6 and 7. This is our merged array here.
Well, it only has what you push into it. So if you've only dealt with the 6 and 7, it'll only have the 6 and 7, right?
We're asking you.
I would think so.
Okay, so then we'll do that then.
Well,
okay.
Now I'm not sure.
Yeah, it's true. I just did a print statement. And as it's going through, before, at the very beginning, because it's the length of the whole, like both arrays. So like if you have,
Yeah.
if you had like these two, then it's just going to be that. And then as it goes through, that merged array will get bigger. So what Desiree was saying was correct.
Good call, Des. All right, what's next?
So I think we skipped a step because that's the part that I'm having a hard time on, is how to get the 6 into the merged array. So we now know that the 6, compared 6 and 7, and we know that 6 is smaller than 7. So how do we get that into?
So when we did elements equals length of array A plus length of array B, that right there, right? And then we did merged array, let's just call it merged. Merged array, we created an array with some placeholders in it, right? For that one then, right? So since this, you said this was, if this is A and this is B, like you said earlier, you said, Tico, there's only one item in each of those arrays. Therefore, merged array should equal only 2 items total because you're only merging those 2 things, right? So there's now zeros because what we did was we made that array equal, sorry, didn't write that right. So it'd be an array of 0 star elements. Elements being the length of both of those arrays together, right? So you just basically, this becomes this, right? And you don't, and so like, you don't have to push these individual items into the merged array. You can just set them equal to whatever index you want, right?
Okay.
Do you see what I'm saying?
Yeah.
So then instead of doing an append or like a push or something, like what would you do?
Just set them equal to the merged array.
You got it. So does that give you a better idea of how we're going about merging these, sorting them? So then basically you would do that all the way through until you got to the end of the list, right?
Yeah.
And then what we need to figure out is how do we keep track of like what parts of this big array of subarrays, how we can keep track of like what we've sorted and what we haven't sorted. Because now you just finished this first comparison, right? Like, how do we know that there's a line right here that says, okay, this has all been sorted over here and then everything over there hasn't been sorted yet? How do we keep track of that? That's the key.
Would it be conditional with the length, comparing lengths of each array?
How could we do that in like Des's code?
Length minus 1. Or you could just increase the index by 1. Or really by 2. You just keep increasing the index by 2. If you're doing.
So let's see, so it would depend, right? Like it would depend, like, so what happens, so this just happens to be sorted for us already, right? Like Des said that 6 is less than 7, so it's already sorted, so we don't have to do anything. We can literally we can bring this one here and bring this one here. What would happen if, like, for instance, yeah, the left item is bigger than the right item?
Could we compare the actual array against the length of that array? So like compare if, because you're saying do to like 2 variables above the for statement?
Yep.
So if we do like A equals array A, and then B equals array B, and compare A and B to the length of, so A compared to the length of array A, and B compared to the length of array B to see whether or not they are the same or different. And if it's smaller, then we need to do the comparison.
Yes,
right?
but yep, that's correct. But like, since you're comparing this right here, so array A, you're actually, you're setting the value of A, that variable, to a whole array. instead of doing that, don't we want to put like an integer here that we can increment or decrement based on what we want, based on what happens at each of these comparisons? Sorry, that probably wasn't that clear. So like inside that for loop, we're gonna have multiple if statements, right? We're gonna have if whatever A is equal to, right? And we're gonna use this as the length, as like the length, I guess. The length of, yeah, the length of A. You know, you're right, Jade. We just have to set this variable though, A, equal to something else. That would be, I guess, indicative of like what elements have been merged and what haven't been, or what elements have been sorted and what have been sorted. That makes sense. Let me see. Hold on. Let me see. I'm trying my best not to give you guys the answer straight up. Like this is so valuable, this process here. All right, so Des, talk me through where your head's at right now.
I'm very confused because where I'm stuck at is translating all of this into code.
Don't worry about the translating part. The translating part will take care of itself. If you understand what's happening in pseudocode, then you can
understand what's happening in pseudocode.
Mm-hmm. Okay. So then talk us through your pseudocode. And you can share your screen now if you want.
So we are passing an array into merge sort. And we are splitting that array up into two halves. And then we are taking those two halves and checking the length of them to see if they are less than, or I'm sorry, greater than 1 or not. And then if the length of them are greater than 1, then we're passing it back into the merge sort array to be further split. And if they're not greater, if the length of them is 1, then we're passing it into the merged array. And then the merge function. And then the merge function is taking in two arrays. I'm not sure how we're passing in two arrays. I guess right and left, but it's taking in two arrays, and we're taking we're figuring out what the length of both of those arrays are. And we're creating a new array with a list of zeros that has the same length as the combination of both of those arrays. And then we are looping through the merged array. And for each of those elements, we are assigning the value that is basically what we're supposed to be doing, because I'm not understanding this code at all. What we're supposed to be doing is taking both of those arrays, comparing the item at index 0 to one another. And whichever one is the smallest, we are assigning to the correct index in the array.
Correct.
And then, or the next index in the array. Then we go back and we compare the first items that are left in the array, and whichever one is smallest, we push that into, or we assign that to the element that is on the array, to the correct element in the array.
Yeah,
Then
like
we keep doing that over and over until both arrays are not until one of the arrays doesn't have anything in it anymore, or a length of 0, and then we just add the last portion of the other array to the end.
there you go. So you do understand the overview there. Line 69 also, I just saw, you have to change the name of the variable split to match what's on line 67.
Length.
There you go. Okay, haven't heard from Tani in a while here.
Well, line 68 has to get changed too. There you go.
To what?
Split has to be changed to length.
Oh, okay.
That's my contribution.
Thank you.
Okay, so you described it spot on. So now that you're passing in left half and right half into the merge function, we're going up to line 53, right? And we're taking the left half and the right half, and then we're breaking it down into elements. And we have this merged array, which is continually growing, and it's equal to the length of array A plus the length of array B, which we saw on the board was like it continues to grow, right? Like it's essentially you break everything down into ones. So yeah, so we need to set that equal to so this is good. This is us taking a chance right here like this. Okay, so if that's what okay, so then now that you have that set up, like what would you do with those variables? Like explain the rationale, Des, like of what you did with why you did A and B there, because you just told me your pseudocode and your pseudocode works.
Honestly, I put it there because you said that we needed to assign them to their.
We do need something there. We do need something there. Okay, all right. Jade, can anybody just take a wild guess at it? If you guys don't get it, I'll give you what A and B are supposed to be equal to. But
you're asking why are we creating those variables?
I know why you're creating the variables. Why are you setting it equal to the actual array? Like, what is the value of setting it equal to array A?
Because those are the individual, like, single arrays or double arrays, depending on how many times. If we're going through it the first time, it's equal to that single array. And we're going to have to compare those to the length of that array.
Okay. I mean, sounds like it would work. So walk me through what would you do next then with these variables?
I would set up a conditional.
Okay.
Because that's what I'm actually trying to do in my code, is set it up to against a variable inside the for loop. I haven't tested it. I've been coding. So I did if A is larger than the length of the array A and B is not larger, smaller. My bad. Sorry. Okay. And B is smaller than the length of array B. I don't know if this is good, but I'm doing another conditional. And I was going to, this is where I was actually going to compare. So this top part is supposed to actually compare whether the lengths are similar. Okay. Then we're actually going to compare A and B.
Okay.
So if array at index A, or array A and then do the brackets and put A inside, is smaller than the array B brackets put small b inside. Then we're going to make merged underscore array with element inside of there is going to equal array A bracket A inside. And that's supposed to tell us that we're putting that array in that position and add it to the merged array.
Very good. Okay, so like what you guys have there, the logic is correct. The syntax is not. So look at line 63 and yep, 63. Tell me what happens if, so basically on line 63 you're saying if the value at the index of A in array A, right? But what is A equal to on line 58?
It's actually equal to the whole array. So would we actually need to put element in there? Oh no, never mind.
Nope.
No.
But no, that's a good thought though, because you're thinking element because it's like an individual like instance, right? Like versus the whole array. Yeah. How else can we get access to, like what is usually passed into the brackets when we want to access something inside of an array? The index. And the index, what's usually the value or the data type of an index?
Should A be 0 and B be 1?
Gotcha.
But actually we can keep both of the variables at 0. So you can just, you can get rid of those and just like A to 0 and B to 0.
Oh, so
I'm not understanding. Wait, what did you? So
okay, so go ahead, walk her through.
0 and B equal to 0.
Now, Jay, can you walk her through why we end up changing those?
I'm actually
trying to figure out too.
Well, a little bit.
Okay.
Of trying to figure out like why did we set those to 0? Is that, are those supposed to be like the indexes of those singular of those particular arrays? And because then if we did that, we would have to iterate afterwards.
Correct. You mean increment? You mean
increment?
Yeah.
Increment.
So it's like a way of making the indices passed in dynamic, essentially.
Yeah.
Right? Instead of hard coding, like it's always going to be at this index, it's always going to be at this one. You're just starting it at 0 so that when you pass in the indices or pass in, A and B, you can change it.
Correct, right? Because you can no longer, like on line 61, when you create a for loop, like you basically, normally you would define like your starting value, your conditional, and then like your incrementer or your decrementer, right? But here you have access to those just by creating variables up top, A and B, set to zeros, and then you can increment them or decrement them based on what you want to do. So, Des, I know that probably doesn't answer your question yet. So ask away.
I mean, so are we incrementing them here?
I think at this first point, you'd only increment the A because we're setting the A into the merged element, correct? At least that's my first thought.
Let's do this so we don't get further in the hole with Des here. So let's put some comments. What's that?
I said I'm pretty far in the hole.
That's what I mean. That's what I mean. So just like Des has been doing up top in her code, she's been putting comments above each line. Let's put a comment for her above each line on what we're doing. So like starting with line 58, let's put a comment right above line 57 then. Like what is A? Tani.
It's the index value for the array A index, I guess, or the integer value. I don't know how to word it, but yeah, it's like your index. I don't know. Can you word it, Tico, better?
That's actually, that
No,
works.
that's
It's
the way
giving
that
us-
works. Yeah, that works.
Yeah.
Have some faith in yourself, girl.
I'm tired. Words are hard right now.
Okay, so recap. Des, do you understand? Does everybody understand? I'm sorry. Does everybody understand the comments then on line 58 and 59? Because before we had them set equal to array A. And so do you see how that would not work on line 63, Des? Like if you have array A at the index of array A, that wouldn't make sense, right? You can't, that's not I guess, an iterable like value.
Before, it was basically saying if the array A was less than the length of array A, which is, yeah, so that's why that wasn't working.
Mm-hmm. Can you confirm, Des, or are you still lost? Because we can keep trying to, because this makes us better at explaining stuff too.
I guess what step in the process is this pertaining to?
This allows you to have access to the, so it's part of the bigger step, but it's like a really, really small, it's a coding syntax thing. Like you need to have.
Yeah, so essentially, Desiree, you're gonna be going through all of the items in the arrays and comparing. Remember how we broke it down? You're comparing one value to another on the bottom line that we wrote. This enables us to move along the array. So it's like you can increment or decrement the indices now, in order to kind of move along them and compare. Does that make sense?
That makes sense.
Okay. So then if we go to line, thanks, Tiny. If we go to line 60, does somebody want to come up with a comment that we can put there for the loop? Like, why are we looping? What are we looping for?
This allows us to loop through the individual arrays of elements. So like how we have length of array A plus length of array B. This allows us to take, so if you have each individual one array, it allows us to do the comparison and iterate through the individual, the two that we keep comparing.
Because the elements, like what is that equal to?
The array A and array B, their lengths.
Mm-hmm.
So
it allows us to loop through the arrays that are being passed in.
Array A and array B. So, you know, remember, Desiree, you're talking about, you corrected me and said we're comparing just the first two, and then we're comparing the next two.
Right.
And we're going to keep putting in array A and array B into there. So this allows us to actually look at just A and B and select them individually. So if you only had two arrays, it's allowing us to look through those combined and do the comparison.
I'm gonna see if I can find a better, like a really good visual example.
So let me just make sure I have this correct. I have allows us to loop through the arrays A and B, so the ones that we're passing into the function, and access each element of those arrays. Right?
Yes.
Mm-hmm.
Because this will actually allow us to start our comparison when we put in the conditionals. Otherwise, we can't do that.
I feel like I dropped the links to these videos. Where are they?
So the next one is
so are we comparing the index to the length of the array?
Yes.
So it's like the current index?
Yes, yes.
Can you guys hear that okay, or no?
Can't hear anything.
You didn't hear anything? Okay. Okay, so just to make sure we're on the same page, do you guys mind if I'm going to share this video real quick so we can get a really fast overview idea here. Okay. Let's see. Okay, everybody see it okay?
Yes.
All right, so let's just watch this together so we are all like,
Today we're going to learn
idea.
merge sort. A few quick points, then we'll get to the example. Merge sort is usually done recursively. When you think of merge sort, as with other recursive algorithms, I want you to think of divide and conquer. We're going to break our problem into smaller problems in order to solve it. Let's get started. We have the following array and we want it sorted. We're going to continuously split the array in half, our divide step, until we are left with the individual items. Watch and see. Our array is now broken down into individual items. One note before we start sorting. When you implement this in code, these steps will be done in a different order because of recursion. But I think this human-friendly order provides more clarity in learning. Let's continue. We're ready to sort. We'll examine the individual items, compare their values, and merge them into temporary arrays.
So that's that comparison we're doing, right?
The temporary arrays are sorted, but there's work left to do. Let's jump up the recursion stack and continue. We merge our smaller arrays into a larger one, inserting items in the correct order. One more merge, and we'll have our sorted array. And that's it. Our array is now sorted. Here's the pseudocode for merge sort. On the left, you have the recursive part, which halves the arrays. On the right is the merge function, which combines the arrays. Merge sort has a worst case time complexity of big O of n times log n. The easiest way to think about it is to start with the merge step. Looking at the while loop, we see we have to visit n items. The log n comes from the maximum height of a binary tree we create, which is on the order of log n. Thank you for watching. Please comment, suggest.
Okay, so visually that makes sense for everybody, right? Like I think the part that we're stuck on is right here, right? Where we're comparing the individual ones, and then those are like put in these temporary arrays, which that would be like the merged
underscore array.
Yeah, in Desiree's code, and that continues to grow, right? Because basically whatever items we're passing to the merge function is the merge function. Like it'll be equal. So this temporary array right here will always be equal to the length of these two combined, right? Because then like this first pass, it's combining only one item or one item from each array. Then the second pass, it's going to combine two items
into a larger one, inserting items in the correct order.
Right here, it's going to combine two items from each array, and that makes 4. So that the length of this one is always equal to that merged, or that length of this one is always equal to the length of these two together. All right, let's share Des's code again here. Okay, Des. What's take a stab at it? What's next?
Give me just 1 second. I'm trying to make sure my daughter is straight.
Okay.
So I gave her the next one, but I'm not sure if I said it right. So I'd like some confirmation.
Sure.
So on the if state, yeah.
Go ahead. I'm sorry.
If the if statement there, the first conditional,
A
equals at the index of 0. So we're comparing if the index value is smaller than the length of the array for both A and B to do the comparison.
So here's where, like I just wanted you guys to get going and write something because we're stuck at a standstill. So I was going to correct you as we went. What mattered is that you got something down. So here, instead of combining those two together, we can split them up into different conditionals.
Yeah.
So like you can split up line 62 into two separate conditionals, right? And basically what you're doing is you're comparing the value for the index, not the index itself. You're comparing the value for it.
Okay.
Yep. And then you're comparing it with the length of array A, right? Because that will tell you if all of the elements in array A have been like merged. Same with all the elements in array B, right? So maybe on line 63, Des, we can put a comment in there. But here, I'm sorry, it's not 63, 62. My bad. So let's look at line 62 again and see if our conditional is correct. That's saying if the value of A is less than the length of array A. So what's the length of array A right now? If we're passing in, let's say we're passing in array A is like just a one item array. Same thing with B.
It's 1.
Yeah, and then what would A be at the start of this loop?
0.
Correct. So then what we're saying is it will run. Then whatever this code is will run, right?
Right.
And have all the elements in array A, have they been merged at this point?
At this point, no.
No. Okay, so then we need to change that line 62 there. We'll need to change it, the direction of the, so instead of being if A is less than, we'd want if A is greater than or equal to the length of array A. Right? If A is less than or equal to the length of array A, which is 1, and then A is like 0 right now. I'm sorry, not less than. I'm out here on my tired grind. Okay. So next line then would be you can get rid of 63, but you'll need that down below. So you turn line 63 into its own if statement that is aligned with line 62, please. Thank you. Yep. And then you're going to take line 64 and you're going to put that up top on line 62.5. And what do we have to change?
What? What? The aluminum foil? Yes, please.
Dang, she even said please to her daughter. Okay, that's what's up. Okay, teaching manners out here. Okay, so what do we need to change on line 63 to make that correct? Because right now setting it equal to array A at the index of A is not correct. So merged array at the index of element is equal to what? So it's not array A at A.
Is it element?
Jade, it's a different array. I'll tell you that. It's array B. That gives you a hint. So in line 63, Des, can you change that from array A element to array B element? And then what should we actually be passing inside of element there instead of element? Right there, yeah. Passing B, right? 0, right? So what is it saying? Does this make sense yet? Tani, are you eating vegetarian Indian food right now, or what?
Let me see it.
I just heated up a veggie burger, so you're so
okay, there you go. Close. Okay, can you talk us through 62 and 63, please?
Sure, let's see. All right, so if our index in array A is greater than the length of array A.
Put it in the oven.
Mm-hmm.
And we want to take this element that we're on while we're looping through the elements array.
Mm-hmm.
Wait, let's see. Oh yeah, we want to set the B, that element equal to the B index of array B.
Mm-hmm. We'll also need to do one more thing on line 63.5, Des. What do we need to do to the variable B since we're just adding it to the merged array right now? We're setting that value equal to an element in the merged array.
We have to increment it.
Boom. So let's increment that B. Yes. Okay, so using 62 through 64 as a template, ladies, how do we write the next one? So how do we write the next? And you can create some. Go ahead and indent on after line 64, Des, because the if statement you have there right now will be used later. But we're going to create the next if statement. So if you had to mirror this for array B, how would you do it? Yeah. 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 I just gotta spell, there's no in merged array on line 66, just gotta put it, yeah. Okay, and then, yeah, what do you do into A there? Okay, so can you explain that? Anybody? Can anybody explain 65 through 67? Like, why are we, like, who cares about the value of B? You know, why are we using that to compare that to the length of array B?
Okay, I'm just going to take a stab at it.
Yeah, please.
It's because we have to, in order to merge everything together, we still need to account for the length of both A and B. So B is doing what we did with A.
Yeah. So like, I know we're looking at lines 58 and 59 as just the index value, but is it also like a counter for us? Like, doesn't it tell us like how many of the items from each array have been like sorted? Like we're saying, okay, go ahead and add another hash mark for the, you know, for the number of items that have been, you know, merged into the array for this array B or array A.
So it's basically keeping track for us.
Yeah. Yep. So Des, maybe on line 59 and 58, maybe we can add something in there to those comments that would help you like remember that those are also variables. Those values are also like counters, almost like they're like counting the number of items that you've already sorted from each of those arrays.
Like that?
Mm-hmm. From array A, right? Yeah. Like from array A and from array B.
Should be the number of values.
Yeah. So maybe we can even, yeah. So we can even like the actual name like of A and B, like instead of having it called A, what can we call it that's more semantic? That would represent like, hey, these are the items that we've already merged, like from array A. Like we've sorted these.
Sorted A?
Yeah, why not? Sorted A. Let's go with it. Good call. So line 58, yeah, let's call that sorted underscore A. Yeah, right? So then, so like right now, before you start that for loop, you're saying, okay, so the sorted number of elements from array A are 0. We haven't sorted anything yet, right? And then as soon as you go through those if else, those conditionals, you're saying, okay, like I just sorted this, mark it off, you know? And then basically line 62, if A is greater than the length or equal to, right? Like, cause you don't want to sort anymore if you've already sorted everything, right? Because that variable is like a counter variable. 58 and 59, they're like counters for us. So that means we have to change 62. So you have to change all the A's and the B's in the for loop to sorted A. I feel like Jade, you're still not understanding yet. You're the only face I can see though. Face. They all face sharing their face.
Mine is confused in solidarity.
Okay.
No.
Sorted.
I think I know what we're doing. I just don't know why we're doing it.
Okay. So we would get a Stack Overflow if we didn't define when we wanted the conditionals inside the for loop to tell us when to stop, right? Like these are, so line 62 is telling us like when all of the elements in array A have been basically sorted, right?
Line 50 what?
Line 62.
Okay, so line 62 is telling us when all of the items in array was sorted. Is that what you're saying?
Mm-hmm. Like it tells us when all the elements, I guess, in array A have been like sorted or merged. Because right,
so that's
they started.
Why we're saying if it's greater than the length of array, then
Yeah.
that means
then you can't sort anymore.
Past length.
Yeah, because you can't go. You can't sort more than what's already been sort. I mean, than the whole length of the array, right? You're like going through the array, using the 4 element in range elements, and then like basically what's happening is sorted A is telling us like, okay, you've already sorted, you know, because 1 would be greater than 1 is greater than or equal to the length of the array because there's only 1 item in array A.
So it's
So
like
this would,
our limit.
yeah. Yeah.
It limits that so that we can't go beyond the fact. If we have, like you said, if we have one item and then we have one item in the array and the length is 1, that just tells us that those are merged. So we're going to move on to the next level of merging.
So like you can never go above it. Like you can never have A be 2 and then the length of the array is 1. You can't do that.
Okay. Right. That makes more sense.
Because once again, like sorted A, that counter variable is also being used as an index on line 63, right? And in indices, you have a 0 and a 1. That's actually like 2 items in an array.
Okay.
Okay. All right, so then the next 2 if statements are gonna look just like what you have in 68. So on line 68, what are you saying on line 68, Jade, with that statement that you had there?
So we're basically comparing now A and B. And we need to say if A is smaller than B, we need to add them to merged array, but in their order, the order that they're in. And so it's a question now of how to enter those into the merged array correctly so that they combine and they'll stay in the same position.
So
we're not adding them here on line 66 and 63 and 66?
Actually, wait a second. No. Merged array A equals array A at the index of A. Yeah, you are.
Okay.
Yes, you are actually.
So then how do we compare A to B? If we're saying that merged array is, if we're already adding those, how do we merge them so that they keep their indices or switch?
Right to the final array. Merged array. So let's see. So 68 is saying compare array A and array B to check which is smaller. The next element in array A is smaller.
Go check your pizza.
So I think the first series of if statements is merging them, but then the second set down below is like the next element in each one. Does that make sense?
It's comparing the elements of each one?
Yeah. So it's still comparing them, but it's comparing the next element in array A compared to the.
Can you say that again, but reference line numbers? Sorry.
Yeah. So, all right. So if we just start back at the top, okay, we have, so if sorted A, if the sorted number of items in array A is greater than or equal to the length of array A, then we're going to go ahead and at the index of element, which would be at this point, it would be 0, right? Because we're doing range elements.
Mm-hmm.
You know what would make more sense if we, like, can you copy and paste this code into that visualizer? Or that would help, Jade?
Which visualizer?
The Python tutor, I believe. Or we could just have we can have Des do it. She has the code open up. I was just asking you because you used Python tutor to your advantage.
Oh, yes. Okay, let me get that set up. Yeah. Give me just a moment.
Oh, how do I do that?
Yep, no problem. So Des, just copy and paste the merge sort and the merge function, both of those together. The whole thing, like from line 53, yep, all the way down to past merge sort. And you're just gonna paste that, that right there, yep, all of that. Paste that, and then you're gonna go to, I think it's Python tutor dot.
Let's do playing a little bit more. Maya, I can't focus on your iPad right now, okay?
It's pythontutor.com. Here, I'll drop the link for you, Des. In the chat here. There you go. I'm sorry, I dropped it in the Zoom group chat. Have you ever used the Python tutor before, Des?
No.
It's really, really a great tool to see what's happening at every iteration.
And you can get into loops without worrying about crashing anything because they put a limiter on it. So you can just keep looking at what's happening. The only thing is you might have to take out some of your comments because they do limit how many lines of code you can have.
So I'm gonna have to jump out soon because I have to do my stand-up.
No problem. As long as you feel like you've I guess have a better understanding than you did before. I mean, not super clear because we're still getting there, but as long as it's better than it was before.
I mean, honestly, I still feel like I'm in the same place that I was.
That's.
I mean, I guess I have a little bit of.
No, you can tell us the truth. You can tell us the truth. That means that we, as people explaining it to you, are not doing a good job then.
No, that's.
That means that
I don't
we
think
need to
that's what that
change.
means. I think it's just.
No, it is. It is.
I don't learn very well this way. Like, period. So.
But like you like that. No, that just means that we're not explaining something correctly. Like if you tell your daughter to go check on the pizza and she doesn't understand what you're saying, then it's because you didn't tell her good enough, like what you wanted her to do. You know what I'm saying? Like you'd be upset if she didn't go check on the pizza when you told her to go check on the pizza because you thought you were explaining to her what you were trying to convey to her. So that just means that we need to work on our conveying skills, right? And that's okay. There's nothing wrong with that. We have to get better at stuff too. So like if you hit the visualize execution button right there. Okay.
Make sure to put a pass after 16 because you have a empty if statement.
Like that?
Mm-hmm. Just indent it.
Like that?
Yep, it should match with everything else and then see if it'll execute.
Oh, check lines 11 and 12. Does like the indentation on that is not, because in Python the indentations have to be perfect. See 11 and 12, it's not lined up with all the other ones. There you go. Okay. All right, indentation error. Okay, if you scroll down.
That you can close out. That's so you can report it to them, but you don't need to, so you can close it.
Okay, if you scroll down, I think there's a button you can hit that says next.
Yeah, outside of this window.
Yeah.
Outside of this window, on your actual
There
browser.
you go.
So yeah, when you hit next, it tells you where it's going to. At this point, you'd actually have to create an array at the very top above these two functions. So you can do like array.
Oh, that was the same thing as that test array that she had, right? She forgot to copy that. So we can just make another array down at the bottom there if you want.
Edit this code, press the edit this code, and then you can add everything.
Okay, so should I do it at the top or the bottom?
You could do it at the bottom, it doesn't matter.
Yeah.
Yeah, just like you had that test array. And then you just have to invoke the function. Oh, I mean, I'm sorry. So your test array equals your array, and then just put some numbers in there. There you go. There you go. Cool. And then we just go underneath. Let's invoke the function.
That.
Okay. Scroll down in the big window. And we got steps 1 through 32 there. There you go. So you want to scroll down so that the bottom of your window will be like right here. So that we can still see this. So you can still see, yeah, there you go. Yep, right there. And you can hit the next button. And then over here, you're going to see a bunch of analysis. So it's going to go line by line for you here. Just keep hitting next. And then just kind of watch what it's doing. So there's your test array. Good. Let's split that in half. That's right. So like it told you length is 10, half is 5. How do you like this tool, Des? It's clear, right? Like you can see what's happening as it's going through the code.
Yeah.
And it moves at the speed that you want to. So.
Should I go faster?
No, I'm just saying that it moves at the speed that you want it to move. And then now we're inside that merge sort function now. Or the merge function. So it's it on local variable new array reference before assignment.
So I think this is because we haven't finished. Could be wrong.
Yeah. Yeah.
Finished the top part, the merge
Yeah.
function.
Mm-hmm.
But
So, go ahead.
go ahead. Oh, I
No,
was
go
going to
ahead,
say, Desiree, I've used this. I've tried not to because it became a crutch for one of the sprints, but it does help kind of explain where everything's going with recursion. So I don't know. This might help you kind of see where everything's at and how it's working.
Instead of having to do it in your head, you can like click the next button and it takes you up here to this function. It's going through here, through here, through here. So even if we went back to, just let us know when you have to leave, okay? But otherwise we're gonna just keep going here. Yeah, keep going back to previous, and let's go to the part where it jumps into the merge function. Because I think that's where some of us are confused. You can also use you can also drag with the little tab item, or the little drag that too. Keep going back. Yeah, like that. So we're gonna go to the part where it first makes that first recursive call, right? Right. We get in there. You gotta go to the right. Go back to the right. There you go. So we make the call. Here we go. We're going in. We define the length. We define half. We say if length is greater than 1, it is. And we call that merge sort function. Half that one, and then we call the new array. Wait. Did we get to the new array yet? Line 29. Did it jump to that point and go up to the what we call merge on left half and right half?
I don't think it's gotten there yet.
Okay.
I don't think it's gotten there yet either.
Okay. Keep going.
Okay, it's here.
Okay. It is here. Turn value none because we didn't finish it. Okay. So it's jumping in there now. Hit next again. Okay. So right here it's comparing those two items, isn't it? Is it not? It's comparing the first two items.
I think it's just splitting that up in half again, isn't it?
Yeah. Oh, yeah. You're right. Sorry.
It's trying to, but since we're down to the least, or to it being single, it's not doing it anymore. So it's kind of stuck because it's of this new array.
Right.
Yeah, it looks like it's stuck. It's hung up on the new array.
So that means that we have to finish those functions up top then, right?
I think so.
Okay. So
I'm still kind of not understanding why we're putting this here, because my thought process is that if the length is greater than 1, if the length of the array is greater than 1, then we want to keep cutting it in half. It's not until after, like if it's not until the length of the array is 1 that we want to actually send it into the merge array.
So you're
Actually,
saying,
can you change the name of line 29 to just array, ARR, please?
so then you're saying, Desiree, you'd put like another second conditional that says if
Yep, and then that one too.
Maya,
Thank
go
you.
check your pizza. I really hope it's not broken again.
You're saying that we would put a second conditional that says if it's equal to 1, then send it to merge sort. That's what you're.
Get it out. I'm sorry. 1 second.
No problem.
This is life.
Okay, go ahead. I'm sorry.
No, you're cool.
All right, Des, it's okay.
You're saying that we need a second conditional that says now that it's the length of equals to 1, that's when we need to send it up to the merge function, correct?
Yeah, or we can just like, because like if it's not equal to 1, then it'll just move on to 29.
That makes sense.
So,
or not, if it is equal to 1, then it'll just move on to 29.
I can tell you right now what you have from line 22 for the whole merge sort function is correct. You don't have to change anything now.
Okay.
Yep.
So basically every time we split it, we want to send it into the merge?
Correct. So basically we're doing like the preliminary step of split all those teddy bears up into their individual arrays until the length of each individual one is no longer greater than 1. Right? Because our goal is to get it down to like a single element. I think Elise told me like when she used that analogy, like you're like breaking everything down and then like when you start sorting, you're building it back up. You like make the array bigger, right? As you go up because you're merging all the
right,
arrays.
But if we send, like, the first time we do this, the first time we do, like, let's say we have the test array, right? The first time we do this, we're sending the entire array into the line 22.
Mm-hmm.
And then the length of that array is going to be, I guess, 10 or 11.
Correct.
And then we're going to cut that in half.
Yep.
And then if the length is greater than 1,
yep,
which it'll be like 5 and 6.
And 5, yeah, 5 and 5.
So we'll do.
You're gonna create new variables called left half and right half.
Variables left half and right half, and so left half will be 20193. And then right half will be 84675.
Correct.
And then, so you want to send those arrays into the merge?
Correct. Yep.
So then what's the point of getting them all the way down to 1 array?
So that you can compare them just by 2s.
Right. I understand, like, that's the point as far as, like, the merge. I understand that that's the point as far as that's concerned. I'm just wondering, like, if we're going to send them into the array after the first split, then
an array of 1 is already sorted, Desiree. So you know that when there's only 1 in the array, it's already sorted.
Right.
So then you're just.
I think the question that I'm asking is that right here, the first time we run this code, we're going to send the array. We're going to send an array of 1, 2, 3, 4, 5 with a length of 5. We're going to send 2 arrays with a length of 5 into the merge, into the merge array.
Correct.
The first time that we do this.
I could have sworn it was after everything gets to 1 individual index.
That's what I was thinking.
Oh, yeah. So, like, remember in the video when he said this, he's like, when you run this recursive function, because of the way recursion works is you're not actually going to, it's not going to work in this order. He's like, I'm showing you this video in like a human, like readable, human understandable order. Like of the things happening when he was breaking things down into single elements, and then he's like building them back up. But if we finish out this merge function at the top right now, then we can plug it into, or when we do the visualizer, it'll work, and you can look at it line by line. Does that make sense?
Okay.
You'll be able to see it. So go up to line 17 and let's start filling this in here, and then I can, then we can see what it says. Okay, so if array A at the index of sorted A, which would be 0. So if array A at the index of 0 is less than the array at the value of array B at the index of sorted B, then what are we going to do? So same thing that you have on line 14. We're going to be setting merged array at the element index equal to something. Yeah. So what are we gonna, where, like, yeah, there you go. You got it. Nice. Okay, same exact thing then for the next conditional statement.
Sorry.
Okay. So actually, if you want, here, Des, you can put at the start of line 18, you can just put an else statement there. And then we just have to pass on line 16 and 13, just have to make those elif merged array. Equal to, does that start to make sense, Jade or Tani?
It's starting to.
Okay. And then just lines 13 and 16, Des, you just got to make those elif. Yeah. So that way it does, yeah. There you go. So to choose only one of those on each for loop, right? Okay. So now if you run this in the code, should, in the thing, it should work. What was the errors giving you over there? Never mind, you just close that. 387 steps, there you go. So we know it's probably right. It's a lot of steps. Okay, so as you're clicking, Des, see if you can walk us through it because you're the one that's most concerned about what's happening with the order here.
Okay, so I've never used this tool before, so I'm gonna try my best.
It's all right. Nobody's judging you here. We're all just trying to help each other out, okay? So that little arrow on the left, that little red arrow, telling you which line we're on.
All right, so the functions are being declared.
Mm.
The array is created.
Good.
And then the function merge sort is called, which passes the array into references the array.
Mm-hmm.
And then it stores the length of the array, which is 10.
Yep.
It cuts that in half, which is 5. And then if the length is...
If the length is what?
If the length is greater than 1,
mm-hmm.
It sends that half, the first half, the left half,
mm-hmm.
back into the merge sort.
Yep.
And then
it's going to do the same thing for that left half that you just put in there, right?
Yeah, so it's cutting that in half again.
Okay.
And then it sends the left half and back into the merge sort again.
Wait, I have a quick question. I don't know why I always forget. The double / does that mean like that means divide this number, the previous number, by the number after the / and then give me the smaller whole number? Is that what that means?
It's like a float.
Yeah.
They'll give you
It's
the
like-
nearest integer. So
Say it again?
So if it's like 7 divided by 2,
Yeah.
the answer is technically 3.5, but
Yeah.
it's not going to split your arrays into 3.5 and 3.5. It's going to give you a 3 and a 4. So it
Okay.
takes I think it rounds to floor.
Okay, it'll be like a math.floor. Okay, thank you.
Okay, so now we're at an array with the length of 1 that we're passing in. And it returns the array.
Mm-hmm. Oh, dude, that's crazy. Did you see what just happened there? Did you see
No.
it? Wait, go back. Okay. Okay. All right. Whoa, that just blew my mind. Okay. Keep going back. I'll tell you right when it happens. Keep going. Okay, now start going forward here. So like it's passing in another version of left half, right? Like it's like keeps passing in left half until left half is like down to 1. Do you notice that? Like, do you notice that there's nothing over here on the right side of Desiree's screen that has 8, 4, 6, 7, or 5 in there? You notice that? Where's 8, 4, 6, 7, 5? It's nowhere to be found because it's not.
It's waiting to go to the next line. So it does this first line first recursively, then
Yeah.
it goes to this next line recursively.
Exactly.
Which-
The order matters. So if you put right half on first, it would do right first.
Yeah.
And then that makes me wonder if once it gets to these recursively, then it sends the combination of that all to the merge.
Yeah. You see that, Des? See on like on the right side of your screen over here where like you start out with this giant array, but then like where the heck is this being left out? Because it just keeps dividing this left side, this left half, until it gets down to 1, and then it like goes down here, returns this, comes down here, and then goes back up here, and then now starts doing the right side, just like a binary search in a tree.
Okay.
So there goes the return. And now goes to the right half. Oh, so cool to have visual tools like this. So now it's going to do the right side.
Okay, so it did the right side.
Wait, did it do the right side or did it just do
It
the?
did both right side. It just did one of them. And then it sent those 2 arrays into the merge as array A and array B.
Uh-huh.
And then
Wait, so it didn't do the right side then, you're right? Like it's actually recursively like calling each of those into the merge function now, right?
so it went back and it did the right side for this for let's see.
Well, it would print those out though, wouldn't it? Jade, Tani, am I going crazy?
It did the right side for this one,
Uh-huh.
and this was the output for that.
It's not
That's what it
showing
returned.
Say it again. Because I don't see the 8, 4,
Does not
6, 7, 5.
Yeah, it does not appear to be. But we haven't done the right half. Yeah.
So I think, go ahead.
So what it did was it came back up here and
Mhm.
it did the right side for this one, and then this was what it returned.
Mhm.
And now it's passing both of these into the merge array, into the merge function.
I feel like I disagree. I feel like it's doing exactly what Jade said earlier, where it does the whole left side, Like so, over here in our, can you scroll down
I mean,
in this window over
so
here,
what
please?
Jade said is what the TL told me in TL hours, that it does, it's like a stack, and you've listed the operation to do to the left half before you listed the operation to do to the right half. So it
Right.
completes all the operations on the left. It goes through and does all the left. And then it goes and does the right side of the left. And then it goes and does the right side.
Can you scroll down right here real quick, please, Des? So like right here, so it's doing only this right now for like everything on the left side, right? Like, so it cut it in half right here, and then what, like right here, and then once it got down to 1, it set this, then it's running this function right here, this small little one right here, right? Or I'm sorry, that's wrong. That is wrong. It's running this one right here, right? Because then this takes us back all the way up to where we'd have to pass in 2 and 0 as our first 2 items that we're comparing, right?
Well, where did it get the 0 from if it didn't touch the right half? How
Right
did
here.
the right half get set?
Well, there is no 0 in the right half, right? There's no 0 on this right half. Like there's 2, 0.
Let me step back so you can see what it did. Okay, so where are we? Okay, so we passed this array in that has 2 and 0 in it.
Mm-hmm.
And it split it in half. It found the length, it split the length in half, and then it split the array in half. Okay, so that's what's returned. And then it put that in there, and because it's a length of 0,
no, it's a length of 1.
It's a length of 1.
Yeah.
And so it's not greater than 1.
Correct. So it should go here. Yep.
It's returned the array.
Okay. Which is this right here, right?
Yeah.
So because it returns that, then it should throw this into the left half, right?
Yep.
So then now it's just going straight back up to the merged, or the merge function.
Oh, it goes to the right first.
So then what okay. So after you click next right here, what happens? Okay. So then it just went right here, right? And then it goes to here. So then really this should be divided right here, right? So we should have an 8 and a 4, right? Hit next again, please. Where's all this at over here? Why is it not printing it?
Because it does everything on the left-hand side first, including passing it into that merge array.
And then so it goes right after that?
It now passes that into the, see now it has passed all of the 2 and the 0 from the last list into the merge function. So like if you look at right here, we're in, oh, sorry.
Yo, I'd be so lost without this thing.
I don't know if it's why it's not letting me. Oh, there it is. Okay, sorry. So it oh, there it is. I'm sorry, it wasn't letting me select it. So like right here, now we're taking those 2 single item array and passing them into the merge.
Into the merge function, yep. Okay. There's sorted A, which is 0, sorted B. Okay, it's declaring those variables, those values. Okay, it's going to go into that for loop, iterate through.
Sorry.
Sorry.
Losing it.
Whoa. What just happened? Did you just hit the last button?
Oh, did I?
I think you might have hit last. You can just drag, you can drag it if you want. You can drag that little thing. There you go. Remember what step we're at? Back a little bit. Keep going. I think it's like 40 or something. There we go. Oh, right around there, huh? Okay, I feel like right. Yeah. Okay. Hit next. Okay, keep going. So we've made that array. So that array was like a 2-element array with zeros. Okay. Sorted A, sorted B. If so, for each item in the range of the elements. So if A is greater than, which is not, sorted A is not greater than, no. So it should go to the next one. If sorted B is greater than, which is not, let's go to the next one. If A at sorted A, which would be 0, right? It's not. So it should go to the next one. I was comparing that, which is 1. So is 1 greater than or equal to the length of array? Yeah, I thought it was. Oh, we're missing a line. Okay. We're missing 2 lines on 17 and 19. Sorry. 17.5 and 19.5. We need to increment A and B again. Sorted A and sorted B. That's what we're missing. There you go. Yep.
Don't forget your underscore.
Oh yeah.
You just can't see it.
Sorted A. There you go. Okay, so now we should be straight now. I think it was like 40 or something, or 50. Oh, there we go. Yeah, let's see.
Wait. Hold on.
There we go. Now we're getting somewhere here.
Okay, so we were here.
Uh-huh. So that means it just incremented B by 1, sorted B. So yeah, you can see down here that sorted B has now been incremented because of that. It's because of this condition here, right? Which said that array A was actually smaller than, or I mean greater than, or equal to, right? Or equal to array B, sorted B, because they're both 0. So then incremented that one. Goes through, then sorted A was just increased now. Right? Sorted A was just increased.
Mm-hmm.
Okay.
So we got the merged array back.
Mm-hmm. Oh, so yeah, it did. Oh, so it's sort of just those two. Okay. But why did it, do you guys see that? Anybody else see that? Can you guys explain it to me real quick?
You're asking why did it,
Yeah, like which of those if-else statements did it utilize in the merge merge function up top. Because the small array that we are now sorting is just 2 and 0 individual elements there.
Mm-hmm.
So which of these statements over here did it use?
I would like to say it used, based off of this information, the else.
Uh-huh.
But I was flipping back and forth trying to look at it. So I think it's supposed to be the else to switch them. But
I think so. Yeah, I think it did that for the first one. And then it like pushed B. Wait, can you go back to that real quick, please, Des? Where it hits this this line right here, and then increments B by 1. Please. Yeah, so hits that one right there. Okay. And then it's going to go back up to the loop, right? Back up to the loop. Okay. And then it hits this line, and A is still 0, so it doesn't do anything. B is greater than or equal to the length of array B, right? So this line right here, this is true now. So it's going to run this one.
mm-hmm.
So it is going to put A in there now, array at the index of sorted A. So then this gets incremented. So then we have now A equals 1, sorted B equals 1, and then it's just going to return merged array, right? Okay. Okay. Thank you.
You're welcome.
Oh, then it goes right back down there. So what's it doing now? It's now doing the right half. 1, 9, and 3. Oh, that's the right half of the array. Okay.
Because it split it in
0
half,
and 2.
and so you had 2 and 0, and then 1, 9, 3. So it's left on the right hand side.
Gotcha. Holy crap! Recursion is like it's like messing with my brain.
It's ridiculous.
It's like when you think you know it, you're like, wait a second. I know it splits it in half and in half and in half and in half and half, but I didn't realize that the order was. Whoa! It's like full circle now. The O log of n runtime makes it similar to a tree. Binary search. Yo, learning stuff all the time. Okay.
Now we're in the right half, left half. And those turn into array A and array B.
Mm-hmm.
So array A is 9, array B is 3.
Mm-hmm.
So we should use that else statement again.
Okay.
After I think it goes through, so you get a merged array, which is.
It's got to create that array first with the zeros, right?
Mm-hmm.
And then it's going to go through and it's going to hit that first.
And
there it is. There's the else statement it hits.
yeah.
Increments B. And then
it should put 9.
Should put 9. It should put 3 in first then, right?
Yeah, 3. Yeah, first and then 9.
Okay.
Return value.
So can you scroll up real quick, Des? And can you like go back like 2 steps? I just want to see exactly which of the elif statements it hit. The second one, I'm assuming that it hit the second elif statement. Yes, that one. Okay, cool. Yep, you're right, Jade. You're right. All right. Looks like we got that baby solved. This was a really good exercise to get my brain wrapped around recursion even a little bit better than it was. Do you feel like it's starting to make more sense now, Des? What's that?
Yeah.
I mean, it's tough when you've been gone, like, and like you don't have any like reps. Like you can't understand something right away as hard as recursion in like one rep. It's just gonna take some time. So, all right. If you got that and you're good, anybody else have any more questions on this? Then we can just help Tani out with her question. Man, I don't know how long it's gonna take to load on YouTube for this. The Zoom video is like 2 hours and 35 minutes right now. Tani, do you want to share your screen now and we can get started on your problem?
Okay.
Jay, did you have the same issues with the same exact problem that Tani's on?
Actually, this is what was puzzling us. Our
Okay.
code is basically pretty close,
Identical?
but mine works and her doesn't. And I don't know if it's because I was staring at it too long, so I can't see the difference. But
Okay.
I have
put
to
them
go.
on that.
Thank you guys for your help.
Yep, no
Hi,
problem,
Desiree.
Des.
Good luck.
See ya. All right, Tani. Walk us.
Oh. I will walk you through it.
Mm-hmm.
Okay. So we're making a queue here. So this is the breadth first, traversal, first off.
Okay.
So first we're making a queue, and this is coming from the queue class that we're importing.
Mm-hmm.
And then we're calling this variable here that I've designated queue.
Mm-hmm.
And we're using the onQueue function,
Mm-hmm.
which is like to add.
Mm-hmm.
So then we're calling that and passing in a node.
Okay.
So then we have initialized a root for our tree.
All right.
All right, so then we have a while loop going on next.
Yep.
We were trying, this is seems to be what's not working. And I've tried different variations of it, like while Q is not none, while Q is, while Q is not equal to none, while Q, this version. I've tried like with a bunch of variations and nothing is
Okay.
working.
Do you want to try? Go ahead. Sorry.
The error she's getting is that when it gets down to the print, it's saying the current underscore node dot value, and it says value is a non-type, or that it's none.
Okay.
And then if you were to move the print below on 123, then it goes to the left and says that's a non-type.
Where was that print statement at? That's why. Okay, so during lecture today, Brian said that there was going to be issues with the print statement on the BFT print. I'm not sure exactly where, but he said that it was going to break your tests. Running that would be breaking your tests. So something about you have to shoot.
I thought it was something like comments from the test, or I don't know what it was either, but I can't figure out how to fix it.
So if you take, can you take this code and then actually try not running the test. Try running the individual file, the binary search tree PI file, and then we can just create our own instance and run the BFT print. So we'll have to create we'll have to pass something in. We'll have to call this function. I think you have to go all the way to the bottom outside of this class. Maybe? Yeah. So what we're gonna have to call that, we have to make a variable for instantiation first.
So we're gonna have to insert it, use the insert. Instead of doing the queue, wouldn't we have to call binary first?
Mm-hmm. Yeah.
So you would actually, do binary search tree,
Mm-hmm.
and then do, is it
Passing a
dot?
value.
Passing a value, yeah.
Mm-hmm.
I can't remember though if you, so you can do like a number, Tommy.
Yeah, like any number that you want it to be the 5, okay. And then instead of new node, do you want to name it something else, like that would represent like it's a tree? BST or something, tree, there you go. Okay. And then we want to insert some nodes here, right? So then we can just go down underneath that. Yep, and then you can do just tree dot, and then whatever method you need to do to insert different values. Yep, and then just put in whatever values you want for these next few nodes. Make like 5 of them or something.
The inside of 149, don't we leave that blank?
Uh-huh. Inside of line 149, that right there?
Yeah, is that like our limit, or is that?
That's our value at the current node. So that would be like, that'd be like a root, I think.
Okay, all right, okay, thank you.
Mm-hmm. No problem. And then, because if you initialize that with a value,
Mhm.
and then self.left, self.right would be none, right? Because it doesn't have any children yet. It would just be just the root
Okay.
itself.
No, we need, okay, cool, thanks.
Yeah. Mm-hmm. And then tiny line 50, are you allowed to have more than one parameter for the insert method? Like if you go up, because it's expecting only 1 right now, right?
Yeah.
It's wondering like what's going on. It's like this girl is trying to get me high on some leaves right now with these leaves. Okay, cool. Let's see what happens now. So now if you just run the file, let's just try to print tree. Or would you have to do a repr? Try it. Do print get tree. There you go.
Might have to do a repr.
Yeah, we gotta do repr, you're right. So we'll go all the way up to the top, and inside of your, that class, let's do a def. I don't remember the syntax, so I have to look it up.
It's def, then the 2 underscore repr.
Something like
I know
that,
it stands for. I know it stands for represent. Yeah. I know that.
And then I think you have to pass in self.
Yeah, you gotta pass the self.
And then what do I do?
And then you could do print.
And then whatever I want.
Yeah, print, and then whichever one you want. If you want to use the F string, you can, or you can just leave it. So then it would be the curly braces, and then you do, I don't know, value, right? I bet this is the only part. I think it would just be value because that's all we're trying to get.
Actually, we're gonna return instead of print.
Return? Okay.
Yeah. Yep.
This
for
is
the I think for the stir one, you might. I think stir you return.
Okay.
Actually, I don't know.
This is where I get a little confused on.
What am I returning?
You're returning an F string, like Jade was saying.
So, and you could probably return the value.
Oh, okay. So I'm reading this right now. Like the purposes of the underscore stir, the double under stir, and the double under repr. So, like, what happened when we just printed out that tree object is it just printed out the location of that tree in the actual memory. But when you put repr on there, repr stands for represent, and it's supposed to represent the official string representation of the object, whereas the double underscore string represents the informal string representation of the object. So that's why Beej said, and I remember you saying this, Jade, you said that Beej said if string doesn't work or str doesn't work, try repr, right?
Mm-hmm. Yeah.
Because sometimes there is an informal representation and sometimes there isn't an informal one, but there will always be an official string representation of an object.
Yeah.
So repr should always work, really.
So I have to say self.value?
I think you have to say self, yeah. Self.value.
Yep.
That's weird since it's in this. Oh, there's it the first time.
I think it's because there's multiple self dot, or because you're saying it's this value inside there, I believe. Could be wrong.
Okay.
So why is it only printing 5? It should also be printing out the other nodes, right? Because tree is more than, at the bottom, we have insert 19852. So really we should be printing, so maybe we need to check the insert function. Make sure insert function's right.
It is, because I checked it in lecture.
Okay. Something is not adding those in. Something is not adding those in. Let's see. Let me see your insert function again here real quick, please. Let's see, as input the binary string here. If self.value is greater than value, if self.left is none, self.left equals binary search tree value. Else, we're saying self.left. Okay, so for line 28, is there a reason why you're returning that on line 28? Is there a reason why you're returning it versus just calling it? Because I think the return stops, the return will stop it, right?
I don't remember. But I do know that it's passing all the tests.
Okay, try it without the return one time.
Oh, I guess I didn't need to do that. So it's still just printing 5.
Okay, let's go back up and let's see again here. Self.left.insert value. I want you to leave the returns out, please. What do you have in the elif down at the bottom? Okay. Self.value. If self.right is none, self.right equals binary search tree passing in value, else self.right insert value. Okay. Jade, what is yours? Looks exactly the same. Your insert function.
Yep.
You didn't have the returns, or you had the returns in there?
I had the returns in there.
That's how
Okay.
it is. I'm not sure.
Okay. Huh. That's weird. Okay. I'm perplexed actually myself. So because we're running the insert function is not doing anything. Can you try a print function down at the bottom right after the first insert, please? Bianca. 5. What the heck?
So it's not reading any of the insertions.
Uh-huh.
Mm.
Jade, how'd you get yours to work?
It's passing, but I'm at the same exact spot where.
Oh,
yeah,
okay.
I just tested all of this through the actual test.
Yeah. Got you. Insert. Okay, so if you look at the insert function, we see that checks if the new node's value is less than our current node's value, right? So can you walk me through the insert function and like how we're doing that? Maybe we could find something.
Okay.
Talk out loud so I can soundboard things.
If self.value, which is, I'm saying like the roots value,
Mm-hmm.
if that's greater than the value we're passing in,
Mm-hmm.
and if self.left is none, so if there's no root on the left side, then your new value is going to become the left root. So self.left equals binary search tree, and then we pass in value.
If there's no root for the left side, new value becomes the left root.
Yeah, so the pointer becomes the new value. Basically, right? That left pointer is moved to this new value.
So if self.left is equal to none, if self.left
Self.left is if it's pointing to none, then that's where you insert it.
Yeah, thank you. That was much better.
Self.left, and that's your insert. Okay.
Okay. But if there is a root for the left side,
Uh-huh.
then we're gonna insert this value.
If there is a root for the left side, add new value as child of the left root.
Actually, instead of saying root, wouldn't you want to say node? So that's more kind of open-ended.
Uh-huh. Or like parent, yeah.
Parent, that would work.
We'll do both.
Let's see. What does your init method look like again? Mm-hmm. What the heck? All right. For your conditional statement, you should already have it running right now, right? Yeah.
Yeah, it is. I was just checking.
Oh, okay. In your F string for the repr, can you also print out your self.left and self.right, please?
Mm-hmm.
Maybe just put like a, yeah. We're missing something, guys. We are missing something. Python is.
Oh man.
Wait, it just.
What?
I just ended up getting.
What?
Something slightly different where it did. The value is none. Value is 10. It's actually showing me everything.
What?
Let me see where it's showing me this because I
Yeah,
actually.
Can you share your screen, please?
Yeah. Let me set it up. I'm trying to set it up. Huh?
Oh wait, you just got it.
Yeah, that's what I'm getting.
Oh no, that's because we just changed the F string. That's right. I'm sorry, but it's still.
But
it's printing the other numbers.
Yeah.
Is what's
so
happening.
That means. Okay. All right.
So we have to print out the pointers.
they're being inserted, but yeah. Okay. Oh, wait a second. We don't have the node class in here, do we? It doesn't know how to print anything because there's no node class. Like we are.
Oh,
The binary.
to actually set up a node.
The double
Yeah,
link.
yeah, we need like the node class in order for it to know.
It should be though. We're importing it, right? Like from.
No, look up top there. We're only importing queue and stack at the top of this file.
Oh, so I have to import node as like list.
Yeah.
Oh.
Yeah.
Do I import list node? Or wait.
Is there a yeah?
Because this is double linked list right here.
That's doubly linked list?
Yeah, this one up here is the list node.
Okay. Yeah, can you import that, please? There we go. The value is 5. Oh, wait, no, left, the value is 1. Oh, no, that's right. Because, yeah, it starts nesting things now. Do you notice that? So if you take out, go ahead and go down to your print statement at the bottom of this and change your F string so it doesn't have those comments. Because now, like, you'll see how it nests things. Yeah, so you can just, you can just take that out. And then 162. Try printing just the first one, 156. Can you comment that 162, please? Thank you. So now we should see 5:1, right? There you go. So where's it at? The value is 5 left. So that means the left value of that is the value is 1. So this is being imported from your list node file from the doubly linked list. So if you go and change the list value is, you could probably take that off of there too.
I'm sorry, what?
So I'm assuming in your list node class, like
Yeah.
when you print something, it's also printing the value is. Is there a print statement anywhere in here that says like the value is?
I didn't write it, but it doesn't look, no, there isn't.
Or maybe it's inside of the binary search tree file? Or doubly linked list? You didn't get it from doubly linked list though, right?
Yeah, I'm not.
Yeah.
I mean, maybe I'm supposed to do doubly linked list because that's where.
No, this is fine. What you're doing is fine. I just want to get rid of the value is F string. So like maybe.
Oh, isn't that? Didn't we put that in the binary search tree for the repr?
Oh, that's right. That's right. Yeah. Can you go up to the? Good call. Can you go up to the repr, please, and remove that? Yeah. Just the string part of it. You can return like the rest of the stuff. So you just need like.
Wait, what do you mean just the string?
So take out the F and then the 2 and the value is.
Okay.
Yes, we can hear.
Oh, you're saying print like self.value?
Yeah. You're coming in and out, Tico. And you're muted now.
Okay, I can hear you guys. Can you hear me?
Yes, now we can.
Okay, cool. There you go. Yeah, like that. Actually, I think you need F strings though, right? Or
yeah.
F string backticks.
Yeah.
I mean, I don't need. I could take out the curly braces.
Oh.
Right.
Yeah, that's true. Yeah. You don't need the yeah.
Except get the commas. Right? Or.
You have to pass the parentheses still, though, right?
I thought it was optional.
To have one return value.
Okay.
Because you can only return one thing. String return non-string type, so it's a tuple. Oh, we're given a tuple. Yeah, so we might want to do the F string, and then just have the no actual string in there, just F. Yeah, and then have the curly brackets again around those. And then they'd only be separated by the commas. Yeah. There we go.
That cleans
That's what
it
I'm
up.
talking about. Yeah, it does. Okay, so that's saying that F is the root, or 5 is the root node, or 5 is the parent, right? And then 1 comes in and is the child of 5. And the child of 5, 1, has a left value of none and then a right value of none, correct?
Mm-hmm.
So maybe we can put that in there. That might help clarify things out too there, Tani. So right in front of the F string on line 15 for self.left, put left equals for in front of the self.left. Yeah, instead of in front of the self.left. So just right here. Yeah, and then same thing for the right. And then now when it starts nesting things, yeah, left and then equals, yeah, like that. And then same thing for right here, yeah. And then now when it prints, it'll look nested, but it'll be right. There we go. So maybe we should put value right in front of here. That will clarify things out too. Value equals, there you go. Okay, so value equals 5, right? The left equals value equals 1, which is the node, which has a left of none and a right of none. But then that right over there is actually referring to the original value 5's right, correct? Does that make sense? Like that looks really confusing, doesn't it?
I get it though.
You see it?
Yeah, I'm seeing it. So basically you have your root, which is the beginning value. But when you have it say left equal value equals 1, that's saying on the left-hand side, we have the value 1 as a child of 5.
Yep.
And then at the child of 1, there's this left off none.
Yes.
But that's just because it's empty.
Yes.
And then it's saying these right pointers are empty as well.
Right. But then the right pointer, that last one is in reference to 5, right?
Yeah, I think so.
Yeah.
Because it's just showing that we're waiting for that next node to be filled in.
Okay. That makes sense now. How could we write that to clarify it a little bit? Because it is confusing right now. Huh? Yeah. You could probably get rid of those like spaces too if you wanted.
Yeah, I was just thinking that.
Oh yeah. And then same thing for, or do you want to leave that? It's up to you. Yeah.
That's fine.
Oh, that's starting to make a little more sense now. Actually, when you leave that equal sign there, it does let me know that it's a root, or it's a parent node.
Parent node.
Yeah, that's pretty nice. But then why is the last one? Why is there 2 rights? Oh wait, never mind. The last right is for it's for 5.
It's just not putting them together for some reason.
Right. Okay, got it. Cool. So what are we looking for now? We did the print and it printed everything.
So we're
what was
trying
the
to
original?
do the
test.
The breadth.
Oh, BFT, right?
Yeah, BFT.
Okay. So go ahead and run the BFT on that one then, because then it would actually print the value of every node.
So it'd be that last print, then do BFT.
Oh, you're saying just use what I have. That makes sense.
Just make sure to comment out the one on 156, because then you'll get a lot of them printing out.
Mm-hmm.
Oh man, is it just BFT?
No, you have to call the method BFT print on the tree that you made it. So you do tree dot BFT underscore print. And I don't think do you need the print statement? Or are you printing inside of that function though? BFT print?
Oh, I don't know.
I mean, I would imagine you would be.
Am I printing? Or am I
Should
returning?
be.
I'm printing. Cool.
Okay, so you don't need, yeah, so you don't need the,
I only have one hand right now.
Because you're eating.
No,
go eat some too.
I have dogs, and
Oh,
I'm just using one hand because they're on it.
Mr. One require. Okay, so we don't have we got to pass in a node in there, right? Because does it? It starts at the top node, right?
So we pass in 5,
Mhm.
or whatever the top.
We just
Yeah.
choose the top node. What
We
if
just
you
pass in 5, right? So attribute value. Oh no, we have to pass in tree. Try passing in tree. Wait a second. Hold on. DFT print. Oh, never mind.
It worked when you passed
yeah,
in tree.
Yeah, it is. So it's tree.bft print, and then you're gonna pass in tree again, because tree.
You're printing the tree.
Yeah. So it means that you're doing the BFT print method on the tree, and then you're passing the tree to B. 51928. That's right.
So it's working there, but for some reason in the test, it's saying that the value is a non-value, a non-type.
Where's it at?
So when she actually does this in the test, it says that the print where she's doing the print current underscore dot value, it's saying that value is a non-type. There it is, right there.
Okay.
And then as you take out, like you uncomment that print,
yeah,
go to the next level, then it says the dot left is not a non-type. It's like every single.
Right. And then the self.
Yeah.
Okay. Can you, I know this has something to do with what he said in class.
Yeah.
But can you go up to the BFT print again, please?
Sure.
BFT print. Okay, so you basically printing that, print the current value, current node equals. Okay, I have current dot. No, current underscore node dot left. Oh, okay. All right, I see what's going on. So line 125, it's needs to be something else. So it's not if self dot right.
Oh, current node dot right.
Mhm.
Oops. I forgot to change that. No way. I'm just gonna go for the test, guys.
Go for it.
Well, just try it. I just want to see. We're already here. Can you just do it, please? It would just be so satisfying. Can you just do it, please? Oh, yes.
Well, that didn't show us anything.
Well, we didn't get an error this time.
But there wasn't an error.
Go to the.
There was, though. Look right
No,
up top. There was an error right
this
there.
guy. No, I was showing you what it said before in the test file.
Oh, right here? This is...
Yeah, I was showing you like my test file.
Oh, okay. Oh, gotcha.
I'm still failing.
Yeah, it's now it's saying int.
Int object. So let's see what line it's at. Line 135 of DFT. That's DFT print.
Well, now I have a new one.
Yeah, now you have a new one.
Change something. Current node.
Okay, so
it doesn't like. Oh, so we were trying to do like a self dot value, but obviously that's not working.
Oh, wait, 130,
133.
133,
Yeah.
not a dot length.
Yep.
It needs to be S dot length.
Gotcha.
So that's the integer. Yeah. So S doesn't have like a attribute of value, so you can't compare it to 0.
I forgot to change it when we were trying everything.
Yeah.
Oh, wait. Why is it not coming up?
Because it probably ran that command multiple times. So if you hit the up button or up arrow multiple times.
No,
there
I
you
just
go.
did the test previously.
Oh,
I failed again.
did you save this file?
Still, yeah. But my computer's been acting weird, so.
Oh, okay. I see. Line 140. What are you pushing in?
Right. Wow. Did I really have this many errors, or was this from changing?
Okay, now we're
Non-type.
getting non-type error again.
Good, we're back.
That's not push. What line is that? 135 in DIT print. Oh yeah. Wait.
Oh, missing parentheses after the length on 133. Because that's a method.
Mm-hmm.
Oh.
Like in JavaScript, you don't need it. In JavaScript, it should be dot length, but in
Good
Python, you need parentheses.
Dave. Oh my gosh.
There it.
I failed still.
Where's it say failure
it's failure 97. That might.
That's the old one.
That's
the.
That's in the test print traversals. That's in the test.
Yeah, I'm just getting there.
That might be the other ones.
97.
Yeah, those are the stretch goals.
Pre-order.
Oh. Okay.
Oh yes, I can comment that out again. Probably in theory, but yeah.
Sweet.
Okay, so it's passing. Oh goodness.
Nice. So, what did you learn? What did we learn from this? Huh?
That proofreading is important.
What is?
Proofreading. Code proofing.
Code proofing? Proofreading? Oh, nah. Like, cause I mean, I would make these same mistakes. Anybody would make these same mistakes. But the value that we should take away from this is like, how do we come to this answer? How do we debug? Like, what do we do?
We
printing.
Instead of going to the test, we printed in the file itself.
Exactly. And you start with the easiest thing that you can see. Like we started with just the first one, right? Like we instantiated a tree, a BST tree, and then like we just try to print the tree. It came up, and then we try to print the nodes after inserting them, and we knew something was wrong because like we were getting the left values and all the other stuff, but we wouldn't get like the, wait, no. We didn't get anything at first.
No, we didn't get anything at first.
So we didn't think it was inserting, but it was.
It just wasn't telling us.
So like this is gonna be like, we're not gonna have each other on the job. Like it's just gonna be us by ourselves, like being able to do this.
Why don't we just work together, guys? We got this. It's an easy fix.
Yeah, they'll hire us for some crazy salaries, and then like basically we all do the work of one person.
Hey, Seattle is I think starting pay is like 90 grand for the average software developer.
Really?
That's
what my friend out there said.
Yeah, it's about right, because that's my husband's friend moved out there for Amazon.
Wow.
I think that's what he's starting around.
My friend is working for Nordstrom, and that's like his starting pay was that a few years ago, and it's like no income tax either, which is nice because that's where we're trying to move next year, hopefully.
Wow.
Yeah, we got some loans to pay off, Tico.
That'd be great.
Big loan.
That'd be awesome.
Yeah, guys, we can all move out there.
I'd actually prefer to stay here because the only thing with living in Seattle is the fog or the non-sunshine, and I did that in San Francisco. I don't want to do that again.
I liked it. I lived in San Francisco before as well.
Yeah, I love San Francisco. You have to live in that area where there's no fog coming in, so you at least get some sunshine. But
I like it. I'm not a sun. I like the rain and snow.
oh no, I need some sunshine. My people are from the sun.
Your people.
We like hot, sunny places.
I mean, I'm from Hawaii, but I hate the sun.
What is
What is
wrong
rain-
with you?
Well, do you have time?
Probably not, since it's being recorded. Or did he stop recording?
What's that? Oh, I'm sorry. I'm still recording.
Oh, I feel bad for everyone. Okay, so yeah, no. Could we do like, I guess, sprint prep?
Yeah.
Wait, do you think it would be kind of us to stop this recording and then do a separate video that's just sprint prep for everyone?
That might be a better idea.
They might be more appreciative.
Yeah.
All right.